Okay, now I'd like to turn my attention to the course itself and then to your part in the course. So let me tell you a little bit about medical neuroscience, more than what you've been able to get so far from the website and the short introductory video. So I'd like to give you a sense of what is the content of this course. Well, the content of medical neuroscience is going to be organized around a set of core concepts in the field of neuroscience. And these core concepts are not original to me. They were defined through several years of work and activity on the part of the Society for Neuroscience, who really attempted to address what are the core concepts in the field of neuroscience that all educated people should know. And surely any survey course of the field of neuroscience ought to include coverage of these core concepts. Now, you can read more about these core concepts at a wonderful website that I hope to encourage you to visit frequently throughout medical neuroscience. The website is called brainfacts.org, and it's a freely accessible site that is supported by the Society for Neuroscience among several other partners. And this should be considered the best neuroscience site on the internet that has the most authoritative, most credible information about this amazing field that you found yourself drawn to, the field of neuroscience. Well, the Society for Neuroscience would suggest there are really 8 core concepts that define this field. And let me just walk you through them. The first, I think, will be quite evident to you as we begin our studies of the anatomy of the human brain, and that is the brain is the body's most complex organ. Soon into the course, we will turn our attention to the means by which neurons generate signals. And what you will discover is that neurons communicate using both electrical and chemical signals. So we'll spend some time thinking about those mechanisms that operate at the molecular and cellular level. We'll turn our attention to the structure and function of neural circuits, and we'll see that the basic neural circuits for sensation, for motor control, and for cognition have a genetic foundation. And these genetically determined circuits provide a foundation for all function within the central nervous system. Now, that genetic determination does not mean that these systems are not changed by our life experiences. Indeed, they are. And this will be a wonderful component of the course where we get to explore the mechanisms of neuroplasticity. And what we'll see is that indeed our life experiences can change the very structure and function of the nervous system. We'll move on then to consider what we might call some more complex brain functions. Really, it's all complex, but I would consider this to be more of an integrative, an associative function of the brain. And it's in this portion of the course that we'll see that our notions of human intelligence arise as the brain reasons, plans, and solves problems. So we're going to want to understand as much as we can about how the brain achieves these important functions. Our next core concept concerns language. And what we'll discover is that it's the brain that makes possible our ability to communicate knowledge through language. Language obviously is very important for human culture and human society. It's also important from a clinical perspective as we consider what a problem with human language might tell us about the localization of injury in the brain. I hope as we study the brain and consider just this amazing organ that we will get to know and understand, at least to some limited capacity, as we pursue that knowledge. I really hope that we don't lose our curiosity and our sense of wonder. And I hope that we even have an opportunity to reflect on the fact that it's the brain itself that gives us this capacity to exercise our curiosity and pursue knowledge and understanding about how the brain works and how the brain interacts with the world around us. And then lastly, our 8th core concept is that fundamental discoveries promote healthy living and the treatment of disease. So we will spend some time in this course talking about injury to the brain and neurological disease of various sorts. But this primarily is going to be a course about the normal structure and function of the human brain. We will use disease and injury as a way to reinforce knowledge about fundamental structure and function. And along the way, I hope to shed some light on current discoveries and current research that is aimed at breakthroughs that will help us translate neuroscience discovery into effective treatment to alleviate human dysfunction and human suffering. Okay, so these core concepts provide a framework for thinking about the story of the human brain that I hope to unfold in medical neuroscience. Well, let me just highlight two other important domains of the course, in addition to our progression through these 8 core concepts. First of all, I'd like to make it clear that our focus is going to be on what we might call systems neuroscience. And systems neuroscience pertains to understanding the organization and function of our sensory systems, as well as our motor systems, and those systems that operate to perform more complex or more associative functions of the human brain, those kinds of functions from which cognition and the various domains of our cognitive faculty arise. And then finally, I would emphasize that in this course, it is medical neuroscience after all, we are going to be concerned with functional human neuroanatomy. And we are going to understand and comprehend the organization of this organ. So we're going to focus on a variety of aspects of human neuroanatomy, beginning with the surface anatomy of the human brain. We're also going to take this brain apart in various ways, and we're going to focus on the parts of the brains that we discover as we begin to dissect through the human brain. We will do the same for a region of the brain that we call the brain stem. And this is a complicated part of the brain, but one that's very important for clinical practice. So we'll consider the surface anatomy of this part of the brain, including the cranial nerves, and then we will consider the internal anatomy of the brain stem, including the cranial nerve nuclei. But we won't stop at the brain stem. We'll extend our studies further inferior in the central nervous system and consider the spinal cord. And we will discuss the internal organization of gray and white matter in the spinal cord, including the long sensory and motor pathways that extend from the spinal cord all the way up through the brain stem and into the forebrain. And I also want us to consider the blood supply to the human brain and spinal cord. And this will give us an opportunity to consider the impact of stroke, which implies an insufficiency of blood delivery to parts of the human central nervous system. And as you'll see, we'll use stroke quite regularly in our discussions of clinical cases as a means by which we can emphasize and apply our anatomical knowledge so that we can understand what part of the injury might be affected in a stroke given a set of clinical signs and symptoms. This brings me to the final point that I would make about the content of the course, and that is that I want you to engage in an exercise of problem solving through the study of clinical cases. Now, you're going to spend quite a lot of effort, especially in the early weeks of the course, understanding the fundamental structure of the human brain and indeed the entire human central nervous system. And this will lay the foundation for understanding how regional focal injury to the central nervous system can impact neurological function. And so what I'm going to do is illustrate for you the importance of having an anatomical framework for understanding neurological signs and symptoms. And what you'll see is that once we understand the structure of the central nervous system, we'll be able to predict what might go wrong with injury and disease to particular regions in the central nervous system. But really what I want you to be able to do at the conclusion of the course is to start with a patient, with the presentation of neurological signs and symptoms, and deduce or infer what has been damaged in the central nervous system. So we're going to work this cycle from both sides, and by the end of the course I hope you'll be quite comfortable relating brain structure to function, both in the context of normal, fully functional individuals as well as those who have had some compromise to the function of some local region of the central nervous system. And a new feature to medical neuroscience that we're quite excited about is the idea of introducing regularly clinical case studies for you that will challenge you to apply your knowledge. And this will help you exercise this general framework of going from clinical signs and symptoms back to the anatomy of the human central nervous system and reinforcing your understanding of that anatomy and its physiology so that you can better understand your patients. So our final examination, looking to the end of the course, is based on this kind of learning. So to prepare you along the way, you can expect to be challenged by a set of clinical case studies. And I hope that you will embrace that challenge and move into the discussion forum your exchange of ideas and your hypotheses about where in the central or peripheral nervous system might there be a single focal injury or perhaps a systemic disease process that would be consistent with the set of clinical signs and symptoms presented in the clinical case. Now I'd like to tell you about the learning resources that we have for the course, and the most important of them will be this website. And I think you'll find that Coursera has provided for us a really rich learning management system that will provide all the resources that you really need to be successful in this course.